All right, so this is number 2 of your number 20. Just remember that when you're trying to put them together as one function of log, um, basically addition means multiplication of, you multiply the arguments. Okay, I need to move this one. Okay, so these are your arguments: x to the 10th, x to the 4th, and I think that's just x. Okay, so when you have a multiplication, addition, and assuming they have the same basis, which is log 4 or base 4, then you end up multiplying the arguments. And if it's subtraction, you divide the argument. But then you have these exponents right here. So let's review a little bit. For exponent, for example, you have 1/6 log 4 x to the 10th. So this whole exponent becomes the coefficient becomes the exponent of your argument. So that becomes log 4 x to the 10th. Make sure you put that inside parentheses, to the power of 1/6. Then of course you can simplify that to log 4 x to the 10 times 1/6 is 5 over 3 after simplifying. So this is the simplified form of that. Okay. Now of course you have to do this thing as well, and also this one. Okay. So now let me just do it one by one. So this is the first part. Now the second part would be 1/8 log 4 x to the 4th. So now this becomes log 4 x to the 4th parentheses to the power of 1/8. 4 times 1/8, that becomes log 4 x to the 1/2. Okay. All right, so they're both log 4. And then lastly, you have 1/12 log 4x. So this one becomes log 4x to the power of 1/12. Okay, so now this and that is the written form of this. So now we can rewrite that. So you have log 4x to the 5/3 plus log 4x to the 1/2. That's 1/2 minus log 4x to the 1/12. Okay, so now you don't have the coefficients in front anymore. So now we can join them all together as one log function, which is log 4. And then it becomes, because these two are both positive, this is positive, positive, so that becomes multiplied to each other. This is negative, so that becomes division. So you have x to the 1/5 times x to the 1/2 divided by x to the 1/12. All right, so that's it. And then you just have to simplify this. Now remember, when you multiply same bases, different powers, when you multiply, you end up adding, and then when you divide, you subtract. So essentially, you're just doing 5. I'm just going to do that here, small space. So 5/3 plus 1/2 minus 1/12. Okay, so that's the simplified version. Then your common denominator will be 12. 12 divided by 3 is 4 times 5, that's 20. Plus 6 minus 1, so that's 26 minus 1, 25 over 12. So now this becomes x to the power of 25 over 12. So this could be an answer, or you can put that exponent back again. You can have 25 over 12 log, I forgot the log 4. Sorry about that. Should be log 4 here, I forgot it. Log 4x. Okay, so this could be, either one of these would be a good answer. So you just have one log power. All right, so let's move on to the next one. All right, so this is number, all right, so this is number 21, I think, the 21st letter A. And so now the idea here is for you to break this one so that it is in, like, it's basically a reverse of number 20. Okay, so now look at your argument. All of these is your argument. Your base is E. You have a numerator, you have denominators. So remember, every time you see denominators, that means it is a subtraction. Every time you see numerators, those are addition. And so you only have one expression, a numerator, but you have two of these. So we can break this one down as something like this. ln, your numerator, fifth root of 30. Now denominator minus ln x to the cube, another denominator minus ln y squared. Okay, you can keep it this way, but you can also change this into exponential. I mean, you can put the exponent in front as coefficient. So now this one, of course, is ln 30 to the 1/5, right? And then minus. So this exponent goes in front. So 3 ln x minus, same thing with the 2 ln y. And of course, this is also an exponent, 1/5 ln 30 minus 3 ln x minus 2 ln y. So you could either go this way or just here. It depends on how simplified your teacher wants it to be. Okay, let's move on to letter B. All right, letter B. All right, so you have that. So carefully look at this one. They have the whole argument raised to the power of 1/6, or all of them under 6 roots. If we were going to rewrite that, that would look like ln of the cube root of 4x ninth divided by z to the 8th to the power of 1/6, right? So that's the 6th root. So if you look at this carefully, you have actually two expressions in your numerator, the square root of 4 and also the square root of x. That's not actually square, that's cube root. Cube root of 4 and also cube root of x to the ninth. And then, of course, you have one denominator. So this will be a plus, plus, and this is a minus. But before that, we want to put this expression, this exponent in front. That would be 1/6. Okay, ln of the cube root becomes 4x to the ninth 1/3. All right, that's the numerator. Minus, because this is the denominator, you still have 1/6 also, because that 1/6 is, it gets distributed, ln z to the 8. Okay, now this, you need to like distribute this. I mean, you can put the 1/3 because the 1/3 goes for both of these, so you can multiply that in here. That becomes 1/18, 1/3 plus 1/6, ln 4x to the ninth minus 1/6, ln z to the 8. And of course, you can also do like this 8, you can also multiply that with 1/6. So, or you can keep it this way, or you can multiply it for more simplified version. It depends on how your teacher wants it. This is not done yet because this one, this is in parentheses. You need to like sort of like distribute, not really distribute, but expand. So now we will have 1/8 ln 4. Now this is getting multiplied, so you will have plus 1/8 ln x to the ninth. All right, minus 1/6 ln z to the 8th. So you can keep it this way, or another way would be like this. Put this 9 in, multiply this 9 with this because that's an exponent. So you can keep it that way, or another version would be 1/8 ln 4 plus 9/8 ln x minus 8 times 1/6 is 4/3. 4/3 ln z. That or that, it depends on how, again, how simplified your teacher wants it to be. Okay, let's see if we can get some more of these. All right, so the next one will be number 22. All right, so you may want to rewrite this. You know that 3 squared is 9, so just make it simplified. So 9 to the log of 9/8. Okay, so remember when you convert exponential to logarithmic, it looks something like this. Say a to the x equals b. So this is your exponential. And if you want to change it to logarithmic, you will write log of base argument equals exponent. Okay, so this one becomes log of your base, which is a, argument is b equals x. That's how you rewrite that. So now if you have this problem, you can just put like equals x here, because that's you really want to evaluate, so you don't know what that answer is. So this one becomes your argument. And so now we can change this one into log form. So you will say log of this base, or that argument, equals the whole exponent, log 9x. And so from here, it's pretty obvious that log 9 is equal to this is 8. Oops. Okay, I just copied that. So therefore, log 9 is equal to log 9, so therefore x must be equal to 8. Okay. I think the next three I will put in another video.